to join me with their camera. We will have Dr. Inzko, that is the CEO of IoT for Zero System from Austria. That is a company that develops IoT and AI solution for the digital transformation of enterprises. Then we have Dr. Ierace, that is the Chief Operating Officer of Intellimech, that is a Lombardy consortium of companies that focuses activities also on technological platforms in the field of mechatronics. And then third, we have Dr. Liani, that is the CEO and Research and Development Manager of Video System, that is a company of Friuli, Venezia, Giulia, specialized on quality and process control. So I directly give the floor to you, starting from Inzko, to present an industrial use case, an industrial application of AI, an AI solution for specific application.
Okay. Thank you, Elena, and good afternoon from my side and from Austria. I try to share my screen, so I need some permission, Elena.
Okay, I should give you the permission. Try now.
So
otherwise, I can share for you. No problem.
Just a second. So I tried again. Oh no, I guess there's a problem with my Mac. So probably you can share my presentation.
Of course.
So
can you see?
No, I don't know if the other participants can see something, but I cannot see.
Okay.
So, okay, now the presentation is here. Thank you. So if you hand up to the next slide, please, some words about us. We are a company located in Klagenfurt in the Lakeside Park, and we were founded 2016, and we are specialized in IoT and visual AI for industry companies. And we have an own developed IoT platform called Cabera, and the first customer of this platform was, I guess the company is quite familiar for you, was Key Data, one of the biggest company in parking facility and skiing area control cabinets. And Key Data used our Cabera IoT platform for predictive maintenance reasons. We are 22 engineers, and I will show you now some examples which we have realized in the industry. And these examples are based on a product we created 3 years ago. It's called Cabera Detect. And what is this system? The system consists out of a control cabinet, an industrial standard control cabinet, because we have learned that it's important to get the AI information very close to the shop floor. So in this control cabinet, there are edge devices for the AI detection, for the visual AI detection, where we connect us to camera systems. And in this control cabinet, there's also the Cabera system, because when we detect some anomalies or certain things on the production units, we have often to react then on after the detection. So it's important that we are able to start processes, and Cabera starts these processes, and these processes are often alarming processes or real-time visualization in dashboards, or we hand over the data we collect with the AI system to other subsystems like an ERP, for instance, like SAP. And the heart of the AI system is a development of us where we are able to copy pre-trained knowledge packs into the control cabinet, and the system can detect the unit we have to detect. So I will show you now some examples in the industry, what we have realized in the last 2 to 3 years. The first example is an example out of the tube industry. So Elena probably can hand over to the next slide. We jump over this slide because time is limited. So to the next slide, please. And if you start the video, I hope this works. Yeah. So the problem was first of all to detect or to train the AI to detect tubes. And if you see on this picture, the tube body is not a very useful sign to train it into the AI. So we decided to train the top of the tube, and as you see in this video, the tubes are completely detected. So what was the use case or the problem in this manufacturing process? Please go to the next slide. So you see these tubes can fall down in the production process. So the real problem is when tubes are falling down on the ground, it's also very risky that the tubes don't fall on the floor, but they fall probably into the gear wheel, for instance. And on the next slide, you see the problem which can happen. So you see the tube is falling down, and if the tubes get into the gear wheel, which you see on this picture, the aluminium body gets around the gear wheel, and the whole production line is standing still for probably hours. So you see, this is a really big problem if this happens, and at the end of the production process, the company is losing money. Thank you. The next slide is from the wood industry. There we detect anomalies on the wood, and you see there the wood is coming out of the slicer, and the wood is going with high movement. It's 120 meters per minute, and we are detecting anomalies on the wood. So if we go to the next slide, there we have a still picture where we see if there is a problem after the slicer on the wood, the AI detects this anomaly in real time with a percentage of possibility, for instance. And the customer said, okay, if the AI detects anomalies on the wood with a percentage of over 60%, then the wood shouldn't go further in the production process. It should be going out of the production process. And so the use case was to level up the quality of the production of this glued wood. In German, it's called Leimbinder. I didn't find an exact expression in English, but probably you see it from the picture. Okay, thank you. The third and last example I wanted to show you is security detection in the industrial surrounding. It's important that people are wearing security clothes, security helmets, and we have made an use case for a customer in Germany. So if you go to the next slide, the process is quite easy. So I hope, persons entering defined areas, for instance, close to a machine, where it's necessary to wear security clothes. So the person were detected from the AI system with the camera, and the AI system checks if security clothes is worn or not. Cavera stores this data in real time. So when are people detected, and are they wearing security clothes or not? And if they don't wear security clothes, an alarm were sent. So please hit the button. Yeah, all the data is stored in real-time dashboards. And another hit, please. The most important reason is that we don't store videos, and therefore the system is also GDPR compliant, because the AI system sees persons, but we don't store any personal information, and therefore it's GDPR compliant. So if we look on the video now how the system works. So please start the video. Okay. We see the person, the AI is detecting the security vest, it's detecting the helmet, and the red box is the special security area. And if the person enters this area, you see the green box gets red. So the AI system recognized the person in the special area, and the process could be now, is the person, or do the person wear security clothes or not? And we will see now when the person will change the clothes that the AI system is reacting in real time. So yeah, the helmet is going away. So another person comes into the picture without security clothes. This is also detected by the system. And the AI system detects everything if the clothes has a different color, for instance, also the helmet. And you see in real time that all the components for security reason, and this is quite important in the industry business, that the people are wearing such clothes are detected completely. So thank you for your attention. These were three examples what we realized. Yeah, and I will hand over to the next presenter.
Thank you very much, Dr. Inzko. There was very, very interesting use cases, and with different applications and different sectors. So very, very interesting. We go on with Stefano from Intellimech.
Yes, thank you, Elena, and good afternoon to everybody. I can show the show the screen. Can you see the screen?
Yes, yes.
Okay. Yes, thank you.
Yes, yes.
Thank you, Stefano Ierace, and I'm representing Intellimech, which is a consortium of companies in Lombardy region operating in the field of mechatronics. What I'm going to present is the project that we have founded also by Lombardy region, which is called the Watchman Workload Reduction Machine Vision-Based Technology Hub for Manufacturing. Very short presentation. This is the idea why we approach this project, mainly for the reason that you can read here, but I want to underline just two main topics. One is the multidisciplinary approach that a company needs when face artificial intelligence approach. And the new kind of competence that we face and that the companies needs, and also it is not something that you can find on the shelf by a research group, but it's something that you need to make different competences around the table. So this is a point that companies sometimes have some difficulties to do, and so we can have to support companies in this topic. And the second one is to create an environment in which companies can test the application before invest. This is very crucial, in particular for small and medium enterprises, which has the necessity to be sure of the value of the the technology once investing in a technology. So it is important to show it the value, the relevance, and also the weaknesses of an implementation of the technology, in particular the AI application. The idea of the project is to create an hub of machine vision technologies, which can support companies in implementing wind technologies in their product or process, based also on some demo case which can provide the effectiveness and also the weaknesses of the application of these technologies. The total project is 6.6 million euro and 3 million euro funded by Lombardy region. So it's a public-private initiative. It's not something which is only comes from the public. And in particular, we have involved the different actors in what I call innovation chain. So the competence provider, the technology provider, and fundamental end user, which can drive the requirements of the application of the industrial applications. Very briefly, the project, and in particular what the use case. The idea of the hub is to have a sort of technology module which companies could take on the shelf and apply in their context, in particular imagine acquisition module, intelligence module, data management module, and collaborative robotics and ergonomics module, and integrate this module in these two use cases, automotive and pharma, and allow to companies to understand how this module and how this technology works. More in concrete, this is a first use case. This is also, you can find also a video here. The use case is about physiological fluid. So as you can see, something and also that impacts on our health. So it's not possible to have error in this kind of product. The challenge is, as you can see, there are different shapes of the bags. The printed test that you can see, it's quite difficult to see, and also due to the different reflection of the liquid inside the bags. And also there are problems related to the bubbles and also other elements which can occur in the fluid. So the companies need to identify to the sort of quality check of this bag, trying to understand the different elements or a bubble or what else is not admissible in the fluid. Very, very briefly, I don't want to go into the technical detail, but at the end of the project, we find a demonstrator which is available for all companies or research center or what else want to see it, in which we recreate the environment, the industrial environment of the companies, and we make the process of quality control. This is very crucial for the companies which can implement this process and so increase their competitiveness on the market. And this is also crucial for other companies which can adopt the same technologies for different application of different products. And other use case is the automotive use case instead. Here the topic is quite different because the impact is not on our health, but is on our on our money, I would say. As you can see, one of the logo that you can find here is Ferrari. And Ferrari, if you buy a Ferrari, you cannot accept some defect in the brake calipers for sure. But the defects of the brake calipers are very, very different from shape and dimension. Just for give you an idea, this defect depicted here is, I think, less than 1 millimeter. Maybe it's something that it's difficult also to see, but it's not acceptable. High color variability, different type and shapes of defect, and also new defect that you have not taken into consideration in your database of defects. Here the same approach. We develop a demonstration in the project We also include the human, the operator, so include also the ergonomic and the robotic issue to assist the operator in the quality control. And this is another application quite different compared with the previous one, since the first one is fully automated, and this is also the operator is partially automated, but it's fundamental also to take into account the operator and to take into account also the way in which the employee and the operator reacts to the technology, reacts to the usage of AI technologies. So this is briefly what our two use cases. What we learned from this project. Just a few points. In particular, I want to underline 2 points of these 4. One is the lack of competencies. When a company, in particular small and medium enterprises, face an approach of AI implementation, needs competence, but not only technical competencies. The AI impacts also on organizational way in which as the companies produce, and so technical are just a part of the competences they need. And the second and the last but not least is the focus on value add. Sometimes we all speak about AI, and the companies thinks that they have to apply AI everywhere. In my opinion, in our opinion, is not in this way. It's necessary to understand where AI should be applied based on the value added that the technology could drive. So that's all. Sorry for my quickness and thanks.
Thank you very much, Stefano. I think that you raised some interesting points that we will try to detail later on in a brief way. But before, I want to leave the floor to Alessandro Liani for the last presentation.
Good afternoon to all. Now I go to share my screen. Okay. I hope you can see my screen.
Perfectly.
Okay, perfect. I introduce briefly Video Systems. Video Systems is a small medium enterprise located in Friuli, Venezia, Giulia. And we are focused on machine vision and artificial intelligence solutions for product quality control and process control on the manufacturing sector. In particular, we start using artificial intelligence starting from 2001 in the automotive market. We have different brands focused on different sectors, like the steel market, the hollow glass market, and the robotic market. Today, we are a 24-people team, more focused on know-how, production, research and development, 15 of us. And then we have a network of partners that produce for us the components to produce the final systems. An important aspect is that the video system is not only a simple integrator, but we develop and produce our embedded smart vision cameras for the industry. In our factory, we have some pilot areas to test the solutions together with the final customer. And we have some laboratories focused on the technologies we use, like robotics, photonics, and optics. And we have an internal NVIDIA-based GPU cluster for the AI and deep learning development. Today, we have more 200 tailor-made applications developed in different sectors. Many of these applications are based on artificial intelligence. And today, I want to talk to you about an application on the food hollow glass market production. First of all, I show you a video. And this is a system that uses machine vision cameras and artificial intelligence engine to detect glass-on-glass problem. The system is focused on finding small glass parts inside the containers. This because these containers are used in the food market for desserts and other foods, and it's very important that are not contaminated by glass contaminants inside. The first application was developed many years ago using traditional machine vision applications, and today is powered with a deep learning engine, and this permits us to increase the capabilities of the system to detect the defects and at the same time reduce the false positive effect. Because a very important aspect on product quality control on manufacturing is to calibrate the capability of identify the defect product instead the not wanted effect of false positive. Good product that is considered not good. Here are some numbers. The first application was developed using classic algorithms and have a 100 capability of defect identification. With we consider a 100 capability to produce false positive. In reality, this 100 is started from 5% of false positive. This was the capability of the system on the starting 2001, 2002. Then we move to classic artificial neural networks for neural networks. And in this case, we increase by 2 the capability to detect the defects and reduce to about 3 times the false positive effect. In the last years, the system is developing using deep learning engines, and in case we have more than 5 times the capability to detect defects and reduce it by 10 times the false positive effect. Okay. Thank you.
Thank you very much. Thank you very much for your presentation. I think that some topics emerge already by your presentation. I want just to start with this question, because we see, for example, in the first presentation that there was also the issue related to the GDPR and in general to the legal and ethical requirements that also the AI solution should satisfy. On the other hand, we talk about challenges related, for example, to the lack of competencies and maybe also, I don't know, correct me if I'm wrong, also some social challenges when we talk about the AI with that somehow interact with the work of the operators. I don't know if it is easy also from the SME and the operators to introduce this type of technologies in their business. And another challenge that we have seen is for example, related to technological problems. So all the technological issues that should be faced to propose a solution that is in line with the requirements. So in your opinion, if there are other barriers, what are the most significant now, and what type of support also you need, for example, to face this type of challenges and to promote the adoption of this type of solution at industrial level?
Yes, today in many areas the biggest problem is connected to the infrastructure of the area, because we know we have a big amount of information to move, and many times is more simple to manage by remote the training phase, for example, of the application. And this is directly connected to the possibility on the area of the final plant to be able to share information from their plant to our factory. This is one aspect. The other one is that many times the final customer is not ready to wait for the training phase. Many times he's used to the traditional technology, and the idea of the customer is to receive the machine ready to work at the maximum capability of the system. But we know when we develop artificial intelligence solutions, if we have not at the starting moment the data set to train the network, we know we have a first phase of training and calibrating of the system.
Yeah, in Austria, we face the biggest problem is that the companies have good ideas in the detection and to prevent problems in the production process, but they only can hardly imagine how the technology is working. So in our experience is that the first step is always to do a proof of concept. So and a proof of concept is the first step. And after the proof of concept, the company said, okay, we can set the system now into a production state. And and the time the timeline is quite long to get from POC status to production status.
Yes, Elena, if I can add one point to the previous references from the colleagues, I want to stress also that, in my opinion, companies may have some difficulties to understand, to make a sort of business plan of implementation of technology, in terms that what implies the usage of the technologies and what does the benefit and also what does the cost. Is not implementing an AI approach is not like build a new machine, put in the plant and switch on and start something different. And this means also more different analysis that sometimes companies need support to do. This is a point. It's not only a question of competencies. It's too obvious. It's mainly one of the main points, but it's also a company to understand from the top management the value and the impact, the business impact of an implementation of an approach like AI.
And do you think that government bodies could somehow help you, support you to face these issues in the implementation of a solution? Do you have already contact or did you showcase your challenges and your achievements also at the institutional level?
Yeah, in my opinion, the support is an indirect support to the companies in this part, because it's a support, as also in the previous panel said, is to support to the context of of demonstrator of use cases which can make clear to the companies the impact of technologies, the adoption, the limits, because I think that we have to also take in consideration the limits of the technology, which is a part that exist, and we without any problem I say that no one is perfect. For sure we have also to underline also this one, because when you apply the technology you also be ready to adopt the risk and to also to make have some problems in the implementation of technologies. But in my opinion, from a institutional point of view, it's important to support this competence center in which or demo case or companies which want to open the door and also to show the application, because this is fundamental to involve also other companies in making the same application or in using the same technology.
Yes, I have the same idea by Stefano, that it is very important, for example, the work of Digital Innovation Hub, because this can be a place to test the technology, to check the limits, and to see the possibility of new technologies before inserting this on the real factory plants. For sure, it's a good starting point.
In Austria, it's oops, camera is on. In Austria, it's quite the same than in Italy. We have also in Austria lots of research projects which are funded by the state, by the government, and these projects are mostly carried out with universities, research companies, and also private companies. And in these technology hubs, you have, like Alessandro said, all the opportunities to test technology, but the most problem is, or the disadvantage is, that the accounting of such research projects which are funded by the states is very, very time consuming, and you have to build up a specialist which is able to document the projects and makes the accounting, because the Austrian state is there very, very complicated, I would say. So for a small private company like us, it's not so easy to get into such a research project, because it's very time consuming from the administration part.
Okay, clear. So in general, also the concept of the possibility to test before investing is essential at industrial level, also in this direction. Last question, also because we are really out of time. It is related also to interregional collaboration. You, for example, Inzko, mentioned this project that are supported, for example, through the different programs by the European Commission, for example. But how much it is important, this sharing of knowledge, this networking of stakeholders at interregional level for the development and the integration of this solution in this need?
For us, it's quite important. I say it quite because it's not so easy to get into such a project as a small company as we are, or in such an Interreg program. It's not so easy to get into it. So in our experience, we are in. It's easier for us to get in a local state research project than in an Interreg project.
Clear. I don't know if others want to.
If I can use a very popular sentence, think global, act local. I would say the market nowadays is global, and so you need to understand what happens in the other countries and in the international and interregional level, surely, because the market is not only at the local level. So it's fundamental, but at the end of the day, you need someone locally, in my opinion, that helps you to, in particular for a small and medium one, to support your innovation process. It's not something that you can do from 2,000 kilometers distance. It's something so. For sure, it's important to share the idea, to this comparison. It's fundamental also to understand what happens in the other countries, but in terms of development application, you need to have someone in your region, in your context, which can support you effectively.
Okay. Okay. Thank you very much for your consideration and for this discussion. I think that yeah, we can close this meeting. I want just to yeah, close with a general overview of what we discussed today. We see that there are lots of initiatives, lots of also strategies that are coming up in these years and in the different regions to support this type of activities, and so the application and the development of the AI solution in the different regions and applied to manufacturing, advanced manufacturing. So for us, it's really important to see that this is a key topic, and we are all aligned in this direction. We also see all these application, these use case at industrial level that was very, very interesting, and that somehow show that there are real benefits for the application of AI. There is space for these technologies. It is a key enabling technologies that could simplify the work and add the value. But of course, as we have already mentioned, there are some challenges still open, and we hope also through our CEUP project to give visibility and give space to these challenges and to possible solution to help and to sustain, particularly SME in this direction. So with promoting the innovation related to the development of AI solution. So I really thank you all for participating.